Alright, we're going to do little things with a series circuit on this heater control motor, showing how the voltage can drop. We can look at available voltage, and we can also look at voltage drop, or what is lost before we send it to the motor. Of course, we have this electric fan motor here then, and then with the electric fan motor we have this resistor board that's mounted in our heater box that's going to give up some of the energy on those individual coils. Earlier we did pull the diagram that gave us a pinout of the A, B, C, and D. We can see that we can have 3 resistors run in series to give up energy, 2 resistors, 1 resistor, or no resistors for high speed on our electric motor. So we're going to pin that out. We're going to hook up a couple of voltmeters, and 1 voltmeter is hooked up for the available voltage at the motor, and that's going to be your meter on your left. And then the meter on the right, we're going to jumper across the resistor and look at the voltage drop that actually came from that. So if I take first off and we do straight voltage to our electric motor, we can see we're running about 10.7 volts on the electric motor. You can hear the speed of it and see the speed of it. Now we said that pin C, which we've already identified, is the output to the motor. Now we're going to work our way down in speed instead of up in speed because we already had high. So medium 2 is pin A. And if I take this and connect this to pin A, instead of 10 volts being applied to the motor, we've only got 8.9. Well, where did the rest of that go? With that, I've hooked the other meter up, and we're going to jump across the shunt in here then. And if I go to this one, I'm directly hooked to the battery. If I come up here across this coil though, you can see I've given up 2 volts, and if I take 9 plus 2, that gives me 11 volts. So I'm using all the energy up in this outside coil. And one thing that I can do to show that I can give up, that I'm giving up the energy, is take a temperature reading of that, and I got 112 degrees on that coil. So no energy can ever be lost, must be transformed into some other type of energy. We took electric and changed it to heat. My next speed up is going to be B to C, and let's watch our numbers there. It's a little bit slower. We can see we only have 7 volts applied to the motor instead of 8, but I'm going to require 2 resistors then to give that up. Coming in with our positive, if I go to this one, I've given up 2 volts there, but 7, 8, 9 volts. Well, where's my other volt at? I have to jump across to this resistor then, and that gives me 4, 7, 8, 9, 10, 11. So I'm going through this resistor and that one to get my voltage. And if I take a temperature test now of these units there then, I should see a little bit more heat with them combined. And I did get 140 there for a second. And I got 126, although this thing's jumping all over the place on my heat ranges. There's a 137. So I've increased the heat here. That means it gave up more energy and less for the motor. Now for my slow speed on this, we've already identified pin D. And if I go to pin D, you can see the speed of the motor. You can see that with the speed of that motor, how much of volts is applied to it, and it's only 4 volts, 5 volts applied to it. So where did the other 7 volts go? I have 2, 3, 4, 5, and there is the rest of it. And of course here's 6.2 volts, 5.2, you add that up, you got 11. But all 3 resistors are giving up energy, and if I do a temperature on this, you can see the 233 degrees on that. So I'm giving a lot of the energy up and only a small amount left for my motor to run on that. Of course, these do get toaster oven hot, and that's why it's mounted inside of there. But again, this has to do with a series circuit using 1, 2, 3 shunts before we get to the device itself and giving up our energy.